you can observe this bulb. What is happening in this bulb is we are providing the electrical energy, right? So whatever electrical energy we are providing, it is converted into light energy and heat energy, right? The energy is getting converted from one form to another form. Now look at this example. Here, whatever chemical energy is there, this is a petrol or diesel, right? So whenever we put this fuel into the car is moving. The car is moving means it is kinetic energy, and kinetic energy is a type of mechanical energy. Now here the chemical energy is converted into mechanical energy. Now look at this. Here the fruits are there. These fruits are at some height, right? So that's why they have got potential energy, and when they are falling, it is converted into kinetic energy. So basically what I'm trying to say is that energy can transfer or transformed from one form to another form. All right, in the universe this keeps on happening. From one form to another form, the energy will be transforming or transferring. Both words you can use. That brings us to the concept of law of conservation of energy. So what does this law of conservation of energy says? It says the energy of the entire universe is constant. That is, energy can neither be created nor be destroyed. It can be transferred or transformed from one form to another form. Just now I have given you some examples, right? What are the examples? Here the electrical energy is getting converted into light energy and heat energy, and here the chemical energy is getting converted into mechanical energy, and potential energy is getting converted into kinetic energy. I have given you those examples, right? So similarly, the energy of this entire universe is going to be constant. Energy can neither be created nor be destroyed. It can be transferred or transformed from one form to another form. Now, the last statement is during the transfer of energy from one form to another form, work is done. So, these are the four important points of law of conservation of energy. Whenever we are talking about law of conservation of energy, people will give this a second point and third point, and they skip this first and fourth point. Immediately they say energy can neither be created nor be destroyed. It can be transferred or transformed from one form to another form, and they leave this first point. So it is neither created nor destroyed means it is going to be constant. So that's why energy of the entire universe is constant. And during the transfer of energy from one form to another form, work is done. I will show you that. All right. Let us take these examples. Now here this boy, he is trying to take this block forward, right? Definitely he must have eaten food, right? So food means what kind of energy it is? Don't you think it is chemical energy? You can also call it as biochemical energy. All right, when he eats it, his muscles are developed. His muscles are developed means it is muscular energy. Now by using that muscular energy, what he is doing, he is pushing this block means, don't you think it is converted into mechanical energy? Definitely the special type of mechanical energy is here, that is kinetic energy. We know about that. But don't you think chemical energy got converted into muscular energy, and muscular energy got converted into mechanical energy? And during this process of transfer, what happened? Work has happened. Now look at this. He applied some force, and this went forward. Then definitely there must have been some work. All right, because work is equal to what is there? Force into displacement is there, right? So force is applying and displacement is happening. That's why during this transfer of energy, work is also done. All right, let us take some of the illustrations. Look at this boy. Now when he climbed to certain height, what he has potential energy. Now he is jumping means he is getting some velocity. Some velocity is there means he got kinetic energy. Right now, if he has 100 joule of potential energy here, now when he is hitting the ground, right? So what will be the potential energy here? The potential energy has become zero because his height has become zero. Now how about kinetic energy? Kinetic energy is 100 joule. That means here whatever energy is there, the same energy will be here also. So what is the kinetic energy here? The kinetic energy here is zero, because right now he was not having any velocity. Now if you add 0 and 100, and here also 0 and 100, so both the times I'm going to get 100. So here kinetic energy is 100 and potential energy is 0, but here it is vice versa, kinetic energy is 0 and potential energy is 100. Alright, let me take one more example here, that is wind power plant. Look at this power plant. Now what is happening here? The wind is flowing. Alright, the wind is flowing means what is that? Kinetic energy of wind. Alright, now due to that, this turbine, whatever this wind turbine is there, no? So this wind turbine, it starts to rotate. Alright, so when it starts to rotate, it is converted into electrical energy and sent it to different parts. Different parts as in different appliances and different, home or factories, it is converted into electrical energy. Look at this, it has reached a factory here, it has reached this distribution system, and it is reaching the electric power station also. Look at this, electric power station. Electric power station, as we have petrol station, right? So electric petrol power stations are there. Now here this car is charged, the battery is charged. Now it starts to move means it is having a kinetic energy. Now in the home you may use some other things like toaster, or you may use any device, any geyser and all. Now there electrical energy is converted into heat energy. Look at this. Alright, so like this, the kinetic energy of wind, is there, no? So that is used to rotate the turbine. Now when the turbine is rotating, so what is produced? Electrical energy is produced. Now this electrical energy is modern source of energy. It can be used for many purposes. Alright, this can be used to convert it into light, can be used to convert it into heat. For many purposes it can be used. Alright, I hope you are understanding how the energy is getting converted from one form to another form, or it is getting transferred or transformed from one form to another form. Alright, moving forward, let us take this hydropower plant. In hydropower plant, what happens here is the water is at certain height. That means the water has got a potential energy. Now when the water is flowing, it has converted into kinetic energy. Now here is the generator, turbine will be there. Here is the turbine, look at this. Now it is getting converted into electrical energy. Look at this. Now what is happening in a hydropower plant? Potential energy to kinetic energy, then to electric energy. Alright, electrical energy. Now this electrical energy can be used for many purposes. Alright, moving forward. Now energy keeps transferring or transforming from one form to another form. Now there are so many examples are given here. You can have a look at these examples. So what are these examples? Now solar energy is there, no? Look at this solar energy. Now this is a primary source of energy. In the previous classes also I told you solar energy is a primary source of energy. Alright, the plants will get that and convert it into carbohydrate, that is through the process called photosynthesis. You must be having idea about photosynthesis. Alright, so it is converted into chemical energy. Now that chemical energy is consumed by the animals, and it can be formed into the fuels also. Alright, look at this. After so many years, the fossil and fuels are produced, no? Fossil and fuels. So whenever these plants and animals are buried deep inside, after millions of years, it is getting converted into petrol and diesel, petroleum products. So that is nothing but fossil and fuels that can be used in the rockets to convert it into mechanical energy, and that can be used to produce electricity also. See, this chemical energy, whatever we are showing, no? So this is nothing but petroleum products. Now that can be used to produce electricity also in the generator. Now that electricity can be used to produce light, and it can be used to run our televisions. And this electrical energy can be used to charge the batteries of car. In turn, it will be converted into kinetic energy. Look at this. Why we are calling the solar energy as primary source of energy is it is the basis. After this only all transformation is happening. So that's why basically what we are saying is energy keeps transferring or transforming from one form to another form. I have given you so many example in this chat. Alright, fine. Now look at this. Now here is a boy. Now he is throwing a ball. from this point to this point. Okay, it is coming from the starting point to end point. Now you can choose 3 points here. This is the first point A, and you can take this maximum height point as B, and you can take this point as C. Now energy at A, energy at point A should be equal to energy at point B should be equal to energy of point C, because energy can neither be created nor be destroyed. Now if you consider the energy at point B, the potential energy whatever is there, no, it is maximum. Now how about kinetic energy? Kinetic energy is 0, because at the maximum height, what is the velocity of the ball? The velocity of the ball is 0 there. Afterwards it is recovering some velocity that is there. Alright, but if you come to this point C, what is the potential energy here? The potential energy is 0. Now how about kinetic energy? The kinetic energy is maximum. Why potential energy is 0? Because there is no height. Okay, there is no height, that's why potential energy is 0. There is a velocity with which it is hitting, so that's why kinetic energy is there. Same is here. So here also the potential energy is 0. Kinetic energy is maximum. Alright, for example, here the kinetic energy is 100 joule, means here the potential energy will be 100 joule. The same has converted into 100 joule potential energy. Alright, kinetic energy is getting converted into potential energy, and again from here to here potential energy is getting converted into kinetic energy. Alright, so it has two motion, no? One is upward motion. You can take upward motion. Okay, in the upward motion, what is converted to what? The kinetic energy is converted into potential energy. Now in the downward motion, downward motion means which point to which point? From point B to point C. In the downward motion, what is happening here? Here the potential energy is getting converted into kinetic energy. Now upward motion means it is from point A to B. What is happening here? Kinetic energy is getting converted into potential energy. Like this, the energy keeps transferring or transforming from one form to another form. Alright, now let us look at this energy analysis of a freely falling body. Freely falling body means, you understand, no? For example, here is the ground level, this is the ground level. Now a ball is falling from this point. Now for example, this is at a height of h. Okay, let me take this is at a height of h. Now what is the potential energy here? The potential energy is mgh. Alright, what is the kinetic energy? 0. Right now we haven't dropped it. That's why kinetic energy is 0. Now for example, if you drop it, what will happen? It will come down and hit. Let me show that here. Now how about the energy here? Here the potential energy is 0. Now how about kinetic energy? Kinetic energy is there, that is half mv square for sure. There is no doubt in that. It is coming and hitting with some velocity, right? So it is coming down and hitting with some velocity here. So it is having kinetic energy half mv square, and definitely this half mv square should be equal to what? Mgh only. So whatever potential energy was here, the same got converted into kinetic energy. That's why you can write it as equal to mgh. Alright, even though if you don't write it, I will show you how it will become equal. Now look here, let me consider this as point A and this as point B. The energy at point A should be equal to energy at point B. Correct, no? What are the energies at point A? That is like a potential energy plus kinetic energy. What is the energy at point B? Again potential energy plus kinetic energy. Now at point A, what is the potential energy? mgh. What is the kinetic energy? 0. And that should be equal to, what is the potential energy at point B? 0. And what is the kinetic energy? Half mv square. Now look at this, mgh plus 0 is mgh, and that is equal to half mv square. I told you, right? So this half mv square is getting converted into mgh, the same equation we got here also. Alright, if you get another point here, C also, here also if you calculate potential energy and kinetic energy, if you add that, so potential energy plus kinetic energy at point A should be equal to potential energy plus kinetic energy at point B is equal to potential energy plus kinetic energy at point C. This is very, very important. So this is the energy analysis of a freely falling body. For a freely falling body, the sum of potential energy and the kinetic energy is same at every point. You can make a note of that also. For a freely falling body, the sum of potential energy and kinetic energy at all points is the same. is the same. Okay, you can take one more example. For example, this is the ground level. Now from this you have thrown a ball upwards. Okay, you have thrown a ball upwards with velocity v, for example. Now it has reached the point, some point here. All right. Now I mean, if you take different situation, consider this as point A, and here also the ball is going above. No, consider this as the point B, and here is the point C. 3 points are there. Now if you take the energy at point A should be equal to energy at point B should be equal to energy at point C. So that is like a potential energy plus kinetic energy at point A should be equal to potential energy plus kinetic energy at point B is equal to potential energy plus kinetic energy at point C. Very, very important. Now here, when you consider at this point A, what is the potential energy? 0. What is the kinetic energy? You are throwing it up with some velocity. That's why kinetic energy is half mv square. Now if you come to point C, what is the kinetic energy here? 0. Why? Because velocity is 0. That's why kinetic energy is also 0. What is the potential energy? Potential energy is mgh. Now if you consider point A and point C, what you should write? Look at this. Potential energy is 0. 0 plus half mv square, and that should be equal to, here kinetic energy is 0 plus potential energy is mgh. So kinetic energy itself got converted into potential energy. This is what law of conservation of energy is all about. All right, fine then. Let us take some of the numericals so that we understand it. A body of mass 10 kg is dropped from a height of 10 meter. Okay, there is a body of 10 kg and it is dropped from certain height. Here is the height. The mass of this body is like 10 kg, and the height of this, whatever this height is there, that height is going to be 10 meter. All right. Now they are asking us find the velocity when it covers half the distance. Okay, very, very important. Now look at this. Half the distance means, you understand, no? Half the distance means here. So this is like from the top at the, what distance it is there? It is 5 meter. 10 meter means half the distance means it must have covered 5 meter. Now it is at a point of height 5 meter. Let me call this point as A and this point as B. All right. Can I write energy at A is equal to energy at B? Okay, they are asking us to find its velocity, okay, when it covers half of the distance. Now it must be coming down with some velocity, no? That's what they are asking about. Now energy at A means potential energy at A plus kinetic energy at A should be equal to potential energy at B plus kinetic energy at B. This is the formula, right? Now what is the potential energy at point A? This here is the point A, right? So what is the formula? mgh. Plus kinetic energy is 0 because it is dropping from there. So definitely the velocity is 0. So therefore kinetic energy at this point is also 0. Correct? No, I hope you are understanding. We are dropping from this point. We haven't dropped that. That's why kinetic energy is 0. And that should be equal to, what is the potential energy at point B? Same formula, mgh. Plus what is the kinetic energy at point B? Half mv square, because it is coming down with some velocity. Look here. All right, m means what? 10. G means what? 10. H means what? 10. Because at point A, it is at a height of 10 meter. And plus 0 you can skip, and that is equal to m. Mass of the body remains same. Acceleration due to gravity is same, into h. H is like, look at this. I mean, at this point B, at what height it is there? It is there at a height of 5 meter. So into 5. Plus half into m is 10 into v square. Alright, so 10 into 10 into 10 is 1000. 1000 is equal to 10 into 10 is 100. 100 into 5 is 500. 500 is equal to, you can do it as 2 ones are 2 fives are. Okay, not equal to 500 plus we have to write. 500 plus 5v square. Alright, so you can do it as 1000 minus 500, and that is equal to 5v square. So let us do this calculation here. Alright, so what is this calculation? 1000 minus 500 is 500. 500 is equal to 5v square. 5 ones are 500s are. So 100 is equal to v square. You can write v is equal to under root 100. So under root 100 is nothing but 10 meter per second. So it must be coming with what velocity? So when it covered half distance, so it must be coming with what velocity here? It must be coming with 10 meter per second for sure. What is the logic we are using here? We are using the logic law of conservation of energy. At point A and point B, the sum of potential energy and kinetic energy is going to be same. Alright, Moving forward to next question. Have a look at this question. Very, very important question it is. A ball of mass 5 kg is thrown vertically upwards. Okay. There is a ball of mass 5 kg. So here is the ball. So it is having mass of 5 kg. Let us consider this as the point A. Alright. It is thrown above with a velocity of 10 meter per second. Alright. Now it will definitely go to certain height here. Okay, and it will stop there. Now when it stops there, what is the velocity there? That is 0 for sure, and let me call it as point B. Find the potential energy when it reaches the maximum height. When it reaches the maximum height means already it has reached here. So now what is its potential energy? Please tell me. Can you tell me what is the potential energy? Now look at this. Energy at point A should be equal to what? Energy at point B. Same thing. Alright, what is energy at A? That is potential energy plus kinetic energy. What is energy at B? That is potential energy plus kinetic energy. What is the potential energy at point A? 0 for sure. Plus what is the kinetic energy at point B? Point A, that is going to be half mv square. And that is equal to what is the potential energy at point B? That's what they are asking. So UB. Plus what is the kinetic energy at point B? So we don't know, that is going to be 0. Alright, I mean we don't know, kinetic energy at point B is 0 because velocity is 0 there. Alright, let us substitute, let's leave this 0, half into m is 5 kg and v square is 10 square, and that is equal to potential energy at point B. Now what it becomes? It becomes 1 by 2 into 5 into 100, and that is equal to UB. So 2 ones are 250s. So 5 into 50 becomes 250. So 250 joule. So 250 joule is the potential energy at point B. That means this is the maximum height. Look at this. Alright. So we are trying to do it with the help of law of conservation of energy. Without this also you can do, but this has become quite easy for us. Now they are asking us to find the velocity with which it will hit back the ground. Now with what velocity you have thrown, with the same velocity it is going to hit back. With the same velocity, 10 meter per second. Why? Because here the potential energy is going to be 0 when we are throwing it above, and when it has come back then also potential energy is 0. If both the potential energies are 0 means kinetic energy must be same. Kinetic energy must be same means the velocity must be same. So that's why the answer for the second one is 10 meter per second. It is going to hit back with the same velocity. Alright, I hope the concepts are quite clear. Okay, so what is law of conservation of energy? Just let us try to do that. Energy can be transferred from one form to another form. Alright, so one form to another form, it can be transferred or it can be transferred, or energy can neither be created nor be destroyed. The energy of the entire universe is constant, and during the process of transferring of energy from one form to another form, what is done during this process from one form to another form? What is done? Work is done. Alright, then afterwards we have done the energy analysis of a freely falling body. So whenever a body is falling from this point to this point, so if you take many points here, alright, this is point A, point B, point C, point D. So potential energy at point B plus kinetic energy at point A is equal to potential energy at point B plus kinetic energy at point B. Similarly, potential energy at point C plus kinetic energy at point C plus equal to, we have to show it equal to, right? So equal to potential energy at point D plus kinetic energy at point D. Same is for the body which we are throwing above. Alright, so during this process also, if you take A, B, C, D, here also the same thing holds good. Alright, fine, then I hope the law of conservation of energy concept is quite clear. Make it sure that you are liking the video and share it among your friends, and don't forget to subscribe. Thank you very much. Have a good day and bye bye.